Alright, this is quiz 9. Study guide. And number 1 on there, let's see. Number 1 asks you, find the length of PQ. Alright, so P to Q. And you're given this circle. You've got a couple of chords in there. And you're told that the arcs are congruent. And this one over here, this chord is PQ. So NM is equal to 2x plus 1. And P to Q is 3x minus 7. And in the circle, or congruent circles, if two chords, or if two arcs are congruent, then their corresponding chords are also congruent. So you're going to take your 2x plus 1, you're going to make it equal to 3x minus 7. So you can subtract 2x from each side. Your 1 is going to equal x minus 7. You can add 7. And 8 equals x. So if 8 is equal to x and you need PQ, you're going to take an 8 and you're going to substitute it into this expression. So you're going to take 3 times 8 and you're going to subtract 7. And 3 times 8 is 24, and 24 minus 7 is 17. So chord PQ is equal to 17. Number 2, find the measure of arc RS. Arc RS.
Teachers, once again, please check your email for the SAT makeup list and send those students to the gym. Thank you.
Alright, this is an example of the converse of the theorem you just applied. Now you've got two chords that are congruent, and in a circle or congruent circles, if two chords are congruent, then their corresponding arcs are also congruent. So arc RS is equal to 5x minus 9, and arc TV is equal to 2x plus 3. So your concept is the same. You take your 2x plus 3 and you make it equal to 5x minus 9. You solve for x. So you subtract 2x from each side, and 3 equals 3x minus 9. You can add 9 to each side. 12 will equal 3x, and then you can divide by 3. So 4 is equal to x. Then you're looking for arc RS, so you're going to take your 5x minus 9, and where the x is, you're going to replace it with a 4. So you got 5 times 4 minus 9. And 5 times 4 is 20, minus 9 equals 11. So arc RS is equal to 11. Number 3, for problems 3 and 4, you're finding the value of x. So in number 3, again, you've got congruent chords. You've got an arc that's 190 degrees. And you're told that this arc down here on the bottom is x degrees. So if these chords are congruent, then their corresponding arcs are also congruent. So if this bottom arc down here is x degrees, then this arc up top is x degrees. And now you've got 3 arcs in this circle. And the sum of the arcs in a circle is 360. So you take x plus 190. So you got 2x plus 190. And that's got to equal 360. So you subtract 190 from each side. And 2x equals 170, and then you divide by 2. So x equals 85. In number 4, you've got 3 central angles. One central angle is x degrees, another central angle is 2x plus 5, and the third is 2x plus 3. In a circle, the central angles sum 360. So same concept. These 3 angles need to add up to 360. So if you take an x plus a 2x plus another 2x, you got 5x. You got 5 plus 3 is positive 8. Alright, so you've combined your like terms. So 5x plus 8 has to equal 360. So subtract 8 from each side. And 5x equals 352. And then you can divide by 5. X equals whatever 352 divided by 5 equals 70.4. Number 5. So problems 5 and 6 both refer to the same circle. And this is circle A. This is circle. There's your symbol for circle. Little dot in the middle. Circle A. And we got B. C, D, and E. And you've got a radius that's perpendicular to a chord. So number 5, you need CE, and you need E to B. Or number 6, you need E to B. The given information is that the radius is 16. Okay, the radius of this circle is 16. So A to B is equal to 16. And you're told that C to D equals 24. So C to D is 24. Okay, so look. Talked about this one yesterday. If you need C to E, if a radius is perpendicular to a chord, then it bisects the chord and its arc. So there was a theorem you wrote down yesterday that said this would be true right here when a radius or a diameter is perpendicular to a chord. So if CD is 24 and the radius bisects it, well then what's C to E equal to? Half of 24, so that's 12. So 12 right there. Now, you need E to B. This is a little bit tougher. You need this piece right here. Okay? If you need E to B, here's what you're going to do. You're going to add a line to this drawing. You're going to add a line from A, or a segment from A to C. That line from A to C represents the radius of the circle. And you're told that the radius is 16. So this piece is 16. Now, A to B is also 16 because it is a radius. So if you can find A to E and subtract it from 16, it'll give you E to B. So this is a right triangle in here. And you know the hypotenuse and one of the legs. So if you label those legs, all right, you got side A, side B, and side C. So if you use your Pythagorean Theorem, A squared plus B squared, which is 12, equals C squared, which is 16. Okay, so A squared plus 144 equals 16 squared, which is 256. If you subtract 144 from each side, then A squared equals 256 minus 144 is 112. And if something squared equals a value, you can find the square root of both sides. That gets the variable by itself. And the square root of 112 is 10.58. And let's go to the nearest tenth. So we're going to make that 10.6. So 10.6. So A to E is 10.6. And A to B, which is a radius, is 16. So EB is going to be equal to 16 minus 10.6. All right? And 16 minus 10.6 is 5.4. All right, again, 7, 8, 9, and 10 all refer to the same circle. So number 7, let's get this circle drawn. Got a diameter and another chord. The diameter and the chord are perpendicular, so all your same rules apply. All right, and let's see. Diameter is 20. Okay, so the diameter of this circle equals 20. LM is 14. Arc LM is 84. Arc LM equals 84. So let's see. Number 8, you need arc LK. And number 8, you need HP. For number 9, you need the area of the circle. And for number 10, you need arc LJ. Alright, so let's see. L to M. From L to M is 14. And you've got a diameter that's perpendicular to a chord. So the diameter bisects the chord and it bisects the arc. If L to M is 14 and arc LM is 84, then arc LK, right here, is half of this 84. All right? L to M, all the way around here, that arc is 84. So half of 84 is 42. H to P. Let's see. If this diameter is 20, then H to J is 10, and H to K is also 10. All right? So if you need H to P, you need this piece right here. If L to M is 14, L to M is 14, then each of these pieces of the chord are 7. So this top piece is 7, and this bottom piece is 7. And since you need H to P, you need to draw in a radius again. So you need to add a radius right here. And that radius is equal to 10. It's half your diameter. So you're going to do the Pythagorean Theorem again. You got side A, you got side B, and side C. So A squared plus 7 squared equals 10 squared. So A squared plus 49 equals 100. And you can subtract 49 from each side. So A squared equals 100 minus 49 is 51. And the square root of each of those square root of 51 equals 7.1. So your A is equal to 7.1. Your A in this case represents H to P. So H to P is 7.1. The area of this circle. Area equals pi times the radius squared. Your radius is 10. So pi times 10 squared. That's pi times 100. So in your calculator, take 100, multiply it by pi symbol. Round it to the nearest tenth. 314.2. And the last question is arc L to J. So L to J. Alright, you said earlier that L to K is 42. So if this much of the arc is 42 degrees, do you see how LK and LJ combined are a semicircle? Okay? So these two arcs, J to L and L to K, sum 180 because they go halfway around the circle. So LJ is going to be equal to 180 minus 42. And 180 minus 42 is equal to 138. So arc LJ equals 138 degrees. Alright, and then your last 5 questions are the symbols for congruent, perpendicular, circle, less than, and greater than. So hopefully you know those by now. If not, find them in your notes or find them in the book and make sure you know how to put them on your answer sheet for tomorrow. Does anybody have any questions on those 10 problems?